Everyone and welcome back to PostNetwork Academy's Data Science and AI lecture series. I am Bindeshwar and today we are diving into a very important concept of statistics, correlation. Have you wondered how we measure the relationship between two variables? For instance, does studying more lead to higher grades? Or does regular exercise improve fitness? These questions lie at the heart of understanding data relationship, and that's exactly what we will uncover today. In this session, we will break down key concepts like the correlation coefficient and its role in measuring relationship between variables. You will also learn how to distinguish correlation from causation, a critical skill for any data scientist or AI practitioner. So let's move. So correlation measures the strength and direction of a relationship between two variables. Correlation is denoted by R and it ranges from -1 to +1. +1, that means perfect positive correlation. Negative, perfect negative correlation. 0, no linear correlation. And let us see the formula. So R is equal to covariance upon under root variance x variance y. Variance of x and variance of y, they are in under root, that means they are under standard deviations. So it means correlation is standardized covariance. That you can say that limits the range from -1 to +1. And this way it measures direction as well as strength of the relationship. In earlier videos I explained you that covariance measures only direction, but correlation measures direction as well as strength. Now some assumptions for correlation coefficient. Linearity. So the relationship between the variables must be linear. Normality. Both variables should follow a normal distribution. Normal distribution here is a probability distribution, continuous probability distribution. We will discuss in upcoming classes in video of probability distributions. Now third one, cause and effect relationship. So correlation does not imply causation. It only measures association. So now it necessary to understand what is a causation. So see some examples. Flipping a switch and turning on a light. Flipping the switch is cause, results in the light turning on is effect. Smoke and lung cancer. Smoking significantly increase the risk of lung cancer. So smoking cause and lung cancer effect. Studying and grades. So more study time cause leads to better exam grades. Exercise and fitness. Regular exercise improves physical fitness. Now let us see one example. So x is 10, 20, 30, 40 and 50. Y 15, 30, 45, 60, 75. X has mean 30 and Y has mean 45. And we will use this formula for the computation of correlation. And see that correlation is free from scale or origin, shift of scale or origin. So we can use this formula in easy way. So let us calculate dx dy, dx square dy square. So in table I have calculated. So if you subtract 30 from x, so you will get dx, and 45 from y, so you will get dy. And dx square, just square it, dy, so you will square dy square, and if you multiply both of them, so you will get dx dy, and plug all these values in this formula, and finally you will get 1, and it indicates a perfect positive correlation. So the correlation coefficient are measures the linear relationship between two variables. Causation is stronger, requiring evidence that one variable directly affects the other. Example, R is equal to 1 perfect positive correlation, minus 1 perfect negative correlation. So this was about correlation. If you want more resources like quiz, PDF, blog post, you can visit website. More playlist like playlists related to central tendency, measures of dispersion, skewness and kurtosis. You can visit YouTube channel, Facebook page and LinkedIn page. And I hope you have understood. See you in the next video and thanks for watching.